Good afternoon, everyone. So, as we have seen in the last lecture, the third version of Euler-Lagrange's theorem. Yes, any student having any doubt about the Euler-Lagrange's theorem and the examples we have solved?
No, ma'am.
Okay. So let us go for the next point. I think in the last lecture we have covered what is the difference between all these Euler-Lagrange's theorem. Those who having any doubt, you can go for the YouTube lecture and you can see that what is the difference. And now, whatever we have seen in the last lecture, it is related to f is function of x, y dash and y double dash, and y is a 4 times differentiable function. Now I can extend whatever we have seen in the last lecture about the third version, that if suppose f is a function of x, y dash, y double dash up to so on yn. I think in the last lecture also I have written. So corresponding Euler-Lagrange's equation can be given as f with respect to y minus d by dx of f with respect to y dash plus next d2 by dx to derivative of f with respect to y double dash minus plus minus plus minus and then finally minus 1 raised to m, then mth derivative and derivative f with respect to ym equal to 0. This will be the corresponding equation. Okay. Now let us solve the example based on this. Everyone should read down this equation. समजते ना है equation काय change आहे? Firstly, we have seen for f is a function of x, y dash, and then x, y dash, y double dash, and we have seen now up to yn. First वाला होगा तो वो इतना ही equation आएगा. Next, and this next one we have seen that in the last lecture, third version. The next equation will be like this. Okay, if it is a function of x, y dash, y double dash, y triple dash, then will be one more term with minus sign d3 by dx raised to 3 derivative f with respect to y triple dash. समजते सगळ्यांना?
Yes, ma'am.
Okay, now let us solve the example for this one. Uh, find the extremal of find the extremal of the function integration of a y integration of 1 plus y double dash x square dx. Okay, in the exam they will not give that which method from all the 6 versions we have. Up to now we have seen the 3 versions. So total 6 versions of Euler-Lagrange's theorem are there. So they are not going to give you which version you are going to explain, or rather which version you are going to use for solving the example. आपको फंक्शन f देख के ही पता चलना चाहिए कि आपको कौन सा वर्जन यूज करना है, कौन सा यूलर लैग्रेंज थ्योरम यूज करना है, राइट? अगर यहाँ पे आप चेक करोगे तो y डबल डैश है, सो यू हैव टू नाउ यूज अवर थर्ड वर्जन, बराबर, एक्स वाई डैश वाई डबल डैश. ओके, यहाँ पे सिर्फ y डैश होता तो आप फर्स्ट वर्जन यूज कर सकते, राइट? यूलर लैग्रेंज थ्योरम. ओके. So in the exam, they will not give you that which Euler-Lagrange's equation you have to use. Okay, you have to verify this. Subject to the condition. Those who are having some difficulties, you can see the example which we are solving. After every theorem, after every Euler-Lagrange's equation we have derived, I have solved one example. So you should compare the example. सगळे example एका पेजवर लिहा आणि कंपॅरिझन करा. कुठल्या एक्झाम्पल मध्ये फंक्शन एफ काय आहे, एफ फंक्शन म्हणजे काय, इंटिग्रेशनच्या मध्ये जे आहे, इंटिग्रेशनच्या साइनच्या मध्ये जे काही आहे फंक्शन एफ, त्याला बघा आणि देन and then you have to decide that which Euler-Lagrange's theorem you have to use. Subject to the condition. What are the conditions given? Y of 0 is equals to 0, y of 1 equal to 1, y dash of 0 equal to 1, and y dash of 1 equal to 1. Okay, these are the conditions given to us. Okay, now we can say that the integral I is now in the form of integration x1 to x2 f of x, y dash and y double dash dx, right? Now what is your integrand f in this case? F is nothing but 1 plus y double dash x square. Now we have to find out the resultant, that is differential equation corresponding Euler-Lagrange's differential equation is given by f with respect to y minus d by dx of f with respect to y dash, correct, plus d2 by dx to f with respect to y double dash equal to 0. Okay, so this equation we must use. Okay, by seeing the function itself, you should decide which Euler-Lagrange's equation you have to use. Since you will have a 6 Euler-Lagrange's equation after completion of a unit number 2. समजते सगळ्यांना?
Yes, ma'am.
Okay, now let us solve this by using our f derivative of f with respect to y. What is the result? F with respect to y dash, that is also 0. Now we remains with only the last term. Derivative of f with respect to y double dash, it is 2y double dash equal to 0. Okay, so we are having only the last term, first and second term will be 0. Now we can have this to be 2 outside and we can write down the derivative d2 by dx to y double dash equal to 0. So 2 can be cancelled once again by dividing by 2. As 2 is non-zero, we can divide. Now what is the derivative? So you can write down this y raised to 4 equal to 0 for the derivative of y. बरोबर आहे का? Yes. Y डबल डॅश म्हणजे काय असतं?
Double.
d2y by dx2 derivative y with respect to x 2 times. इथे परत एकदा आहे ना. So what we will write down? We can say this to be y raised to 4, that is fourth derivative y. Is it so difficult?
No, ma'am.
So we should answer, no? So what is our corresponding characteristic equation will be r raised to 4 equal to 0. So what are the roots? R equal to 0, 0, 0 are the roots 4 times. Now what will be the general solution? I can write down the general solution is equals to c1 e raised to 0, right?
Yes, ma'am.
Plus c2 e raised to 0 x plus c3 e raised to 0 x square plus c3 e raised to 0 x cube. Or indirectly you can solve it direct from the y raised to 4. Okay, y raised to 4 है तो उसको integrate करो, you will get y cube is equal to some constant c1. Then you get y double dash is equal to c1x plus c2. Then again you integrate, you get y1, that is c1x square by 2 plus c2x plus c3. बरोबर? Next, if you again integrate, you get y equal to c1 x cube by 3 into 2, that is 6, plus next c2 x square by 2 plus c3 into x, right, plus c4. Okay, c1 upon 6 ये एक constant हो जाएगा, c2 upon 2 is a constant. So you can see the general solution which we have obtained is c1 plus c2x plus c3x square plus c4 x cube. Okay, same ये दोनों, only the change is what we have obtained this by direct integration, and this general solution we have written with the help of a formula, that is e raised to x के format. Okay. So we can say which is required solution. The general solution which we have obtained is a required solution for our given differential equation. Okay. Yes. Can I ask whether you have solved the example, the basic question which I have asked you, that why we are writing the solution in the form of e raised to? केलेत का सॉल्व? अजून तसंच आहे तो होमवर्क. Yes. You can have at least two answer, na? Yes or no, or somewhere if you have found the answer, you can say the answer. Sanga, why we are writing the solution in the form of e raised to? I have given you in detail idea ना why this solution of any differential equation is not unique. क्योंकि आप अगर C1 C2 के वैल्यूज वैरी करोगे तो आपको डिफरेंट कर्व मिलेंगे. कॉम्बिनेशन ऑफ ऑल दोस कर्व इज कॉल्ड अ सॉल्यूशन स्पेस. तो एक डिफरेंशियल इक्वेशन के लिए एक सॉल्यूशन नहीं होता है. ओके, वी हैव अ infinitely many solution for different values of C1 C2 C3 we get a different solution. बरोबर ना? Agree with me or not?
Yes, ma'am.
सांगितलं होतं ना तुमच्या क्लासवर how the differential equation will have infinitely many solutions. हो तरी म्हणा नाहीतरी म्हणा सांगितलं होते का नाही? Yes.
मैम कंदी सर.
Yes, Kandi sir. Yes, Ajinkya, what you want to say?
मैम घेतलेत मॅम कंदी सर चालू आहे हातभार डिफरन्शियल इक्वेशन.
Okay, that is what I was asking you, no? Why there is need to write down the solution in the form of e raised to? का लिहितो e raised to या फॉर्मॅट मध्ये का लिहितो? होतात का तुम्ही लेक्चरला आधीच? मी विचारले होते 4-5 क्वेश्चन. ई रेस टूच्या फॉर्म मध्ये का लिहितो? ई रेस टू एक्सचा ग्राफ काय आहे?
नव्हतो मॅम.
मायनस एक्सचा ग्राफ. मग परत मी काय विचारले होते? एनी डिफरन्शियल इक्वेशन वाय वी आर रायटिंग जनरल सोल्युशन, पर्टिक्युलर सोल्युशन, कंप्लीट सोल्युशन. Why we give the different name? I think I have given you one more thing that for a first order differential equation, we say it is rate of change as well as a slope of tangent. So I have given you in detail idea why it is called a slope. क्योंकि जैसे आपका h का वैल्यू टेंडिंग टू 0 आता है तो आपका secant कन्वर्ट होता है tangent में. आठवते का सगळ्यांना लेक्चर तो?
Yes, ma'am.
Next, I have told you the rate of change also. For function y equal to x square, we have to find out y dash. Derivative find out करा परत x equal to 2 ला check करा. कसं rate of change येणार? Why it is 2 times a rate of change? I have given you in detail idea and how to solve these basic question that I have told you. और कोई भी आप differential equation जब solve करते हो तो आपको जो initial conditions दिया होता है या boundary conditions जो provide होते हैं उससे आप लोग क्या करते हो? You find out the values of the constant terms, right? After finding the values of the constant term, you just put up again back, and for different values of those constant term, you are getting different curve, and hence the solution of any differential equation is not a unique. बरोबर ना? You get uh, many curve, and combination of all those curve will give you the solution space. That's why we call those e raised to x, e raised to r1x, e raised to r2x, we call them as a basis. Okay, metric space में भी metric vector space है वो, क्योंकि आपका जो metric आप define करते हो वो vector space के सभी properties को satisfy करता है. And maybe after some points in differential equation you will come to know that the whatever the roots you are finding and whatever may be the root, suppose e raised to r1x and e raised to r2x is a solution, that is nothing but the basis. Why we say it is a basis? Because whatever is the solution for any differential equation, एक differential equation के लिए infinitely many curve you can find out, एंड उस कर्व उसका जो सॉल्यूशन स्पेस आपको मिलता है उसके लिए जो बेसिस होता है वो बेसिस ही आपका e raised to r1x and e raised to r2x होता है. Okay, so let us go for the next point, that is we want to now find out the values of the constant terms c1 c2 c3 and so on. For that, let us use the initial condition y of 0 is equals to 0. So we get 0 equal to c1 plus again 0 plus 0 plus 0. So we get c1 equal to 0. Okay. Similarly, now let us go for the next y of 1 equal to 1. So hence 1 is equal to, just we have to put up the value of x equal to 1. So c1 plus c2 plus c3 plus c4. Right, already we got the value of c1 is 0, so you can write directly as c2 plus c3 plus c4 equal to 1. Correct? You can name these equation as some number. Let us name it as some equation 1. This is say equation 2. Now again let us put up the next initial conditions. Y dash of 0 is 1 and y dash of 1 is equal to 1. For that first I should find out y dash of x equal to y dash का येणार आहे that's derivative of c1 is 0 plus c2 plus 2 times c3x plus 3c4 x raised to 2. Is it okay?
Yes, ma'am.
Y dash of 0, now you have to put x equal to 0. जिथे x आहे तिथे 0 put up करा. c2 plus, right? Again 0 plus 0. So you get the value of c2 equal to 1. Correct? Now y dash of 1 equal to 1. Wherever you have x equal to 1, you have to put. So you get the value of a c2 है 1 है plus 2 c3 plus 3 c4. Okay, x equal to 1 you have to put. Then you get the value 2c3 plus 3c4 equal to 0. 1 minus 1 is 0 in it. Okay, so you get the result. We are having the 4 equations in 4 unknown. What are the 4 unknowns? C1, C2, C3 and C4. Already we got the value of C1 and C2 from equation 1 and 3. Barabar? Now
Yes,
this
ma'am.
we remains to find out the value of a C2 and sorry here sorry
C3 and
C1
C4.
and C3 and C4 we have to find out. Okay, now combining these two equation you can find out the value of a C3 and C4.
0, 0.
Yes, it is 0 0. Yes, whether
Yes, ma'am.
everyone has solved this equation 2 and 4 you have to solve. Okay, what you can do for this is you can write down 2c3 is equals to minus 3c4 and then value of this you can put here. That is value of c3 in terms of c4 you can put. You can get the result. What is the equation we have is c2, c3, c4 equal to is answer 1 c is equal to 1 c1 is 0 no. ओके तो C2 प्लस C3 का वैल्यू क्या सब्स्टिट्यूट कर सकते हैं हम लोग यहाँ पे माइनस 3/2 C4 plus C4 equal to 1. Now we have the value of C2 also.
C2,
C2 का
1.
value 1 है correct. So now this 1 get cancelled from the left and right hand side. Minus we are remaining with minus 3/2 c4 plus c4 equal to 1. So these 1 get cancelled. We get c4 into some bracket constant term equal to 0. So this constant term is non-zero. Hence we can say c4 equal to 0. Here we are using the concept of without zero divisor. A into b equal to 0. Okay, let me check here. 1 minus 3/2. So क्या आएगा वैल्यू इसका c4 into 2
Minus
minus
1 by 2.
minus 1/2 equal to 0. So minus 1/2 is non-zero. So therefore product of these two 0 है. ये दोनों का product अगर 0 है तो obviously C4 should be 0. Here we are using the concept of without zero divisor. A into B 0 है ना. So what we should be condition we have either A is 0 or B should be 0. Or we can have A and B both are 0. Is it possible? Product zero होणार है ना.
Okay.
A and B both are 0. Then also product is 0. And next condition is what? Without zero divisor. What do you mean by without a zero divisor or with a zero divisor? The definition itself tell you the meaning. With a zero divisor means zero को divide करेंगे वो लोग. और without zero divisor means they are not going to divide zero. If I say that A and B both are non-zero, A is also non-zero and B is also non-zero. But if I say that the product A into B is 0, then it is called a with a zero divisor, na? Yes, anyone can explain this? This is possible in, you can say if it is having Z, suppose I will be having in the Z6. Okay, Z6 में क्या होगा 2 into 3. 2 is also non-zero, 3 is also non-zero. But 2 into 3, that is 6. 6 is 0. Z6 मध्ये 6 0 है ना?
Yes, ma'am.
That is called a with the zero divisor. क्योंकि वो जो आपके elements है 2 and 3, both are non-zero, but still they divides 0. Okay, by the name itself you should find out the meaning. With the zero divisor मतलब क्या, वो zero को divide करेंगे, right? Without zero divisor means what, they are not going to divide it. Okay, so here we get the value of C4 is 0, so hence directly you can write down C3 is 0 because C4 and C3 में क्या relation है, ये वाला relation है. So if you get C4 is 0, C3 will be 0. Finally, we get the values of C1, C2, C3 and C4, and then we can write down the solution y of x is equals to, in the form of C1 plus C2x plus C3x square plus C4x cube. Okay, what is the value of a C1 we got it is? I think C1 is 0, C3 and C4 both are 0. So here it is 0, C2 is 1 plus this is 0, this is also 0. After solving this much, we are getting only y of x is equals to x. Okay? Which is a required solution. So in this way, you have to recognize and you have to solve the example. Okay, let me ask you one more question, that if suppose the equation is like this, x square minus 5x plus 1 equal to 0, right? So how you write the roots, x square minus 3x minus 2x plus 1 equal to 0, right? Then we write if x is common, x minus 3 minus, you write 1 is common, then you write x minus,
रूट में 6 होगा.
Position कर लेंगे.
wait, we'll find out the roots for this. Okay, just can you tell me what are the roots for this equation? Minus 6x plus x plus 1 equal to 0. So minus b minus b plus or minus b square minus 4ac and given it is. Okay, let us take some different equation क्योंकि यहाँ पे रूट में आएंगे इक्वेशन x square, suppose minus 5x plus 6 if I take. You can get the roots as minus, then it is plus or minus b square, that is 25 minus 4ac divided by 2. So you get the root as plus 5 plus or minus 1 divided by 2. That is, you get the roots as plus 5 plus 1, that is 6 by 2, and
and 2
plus 5 minus 1, that
4 by 2.
is 4 by 2, that you get the root as 3 and 2. Okay, fine. यहाँ पे उसीलिए कंफ्यूज हो गई थी मैं, यहाँ पे 6 आना चाहिए. So you get the roots as 3 and 2, and if you solve it, you can get the solution when we can write it as x minus 3 into x minus 2 equal to 0. And after this step, I hope you remember you write it as x minus 3 or x minus 2 equal to 0, and hence we write x equal to 2 or x equal to 3. You write like this only, no? My question is why you are writing or here? आठवते का? I think in the 8th or 9th standard we have done this type of a polynomial we have solved. So my question is, the after this step, okay, यहाँ पे 3 आना चाहिए, यहाँ पे 2, okay fine. So here यहाँ पे क्या लिखते हैं हम लोग, x minus 3 into x minus 2 equal to 0, then we write x minus 3 equal to 0, or x minus 2 equal to 0, then we write x equal to 3 or x equal to 2. My question is, why you are writing or here? आठवते का सगळ्यांना or लिहित होते ना का and लिहितो?
और
Yes, ma'am. Or
Okay, why there is need to write down or? क्योंकि दोनों भी रूट ही है ना आपके इक्वेशन के, x equal to 3 as well as x equal to 2. Both are the roots. Then why we are writing or? Can I write it as x equal to 3 and x equal to 2 are the roots? If so,
quadratic equation आहे त्याला 2 रूट असतात. 2 roots.
no root we get the 2 roots.
Then satisfy that equation. 2 roots.
Obviously they are going to satisfy the equation. That is not a problem. क्योंकि हम लोग को पता है कि ये इक्वेशन सेटिस्फाई करेंगे, दे आर रूट्स ऑफ इक्वेशन, दे विल सेटिस्फाई. माय क्वेश्चन इज व्हाट, व्हाई वी आर राइटिंग और का लिखो. आई डोंट रिमेम्बर कि मराठी में क्या लिखते थे आप लोग, बिकॉज आई एम नॉट फ्रॉम मराठी में.
मैम ज्यादातर तो
कैसे?
कॉमा ही लिखते हैं.
हाँ कॉमा लिखते. Yes, anyone, because everyone has studied this type of a polynomial we have solved in our 8th and 9th and 10th standard. Many polynomials we have solved quadratic equations. But we are writing or in between those. Okay, try to solve this question why we are writing or. क्योंकि दोनों अगर रूट्स है तो और नहीं लिखना चाहिए ना, एंड लिखना चाहिए वहाँ पे. इसका मीनिंग ये है कि हमने जो भी स्टडी किया है 8th में वो रॉन्ग है, बरोबर ना? If you want to write down and. Yes, everyone getting my question?
Yes, ma'am.
And because of any value of x putting in above equation we get 0. If we put and then we not get 0 above equation.
If we put and, why we are not getting 0?
x की वैल्यू 3 जो है ना वो x के इज इक्वल टू 3 और x इज इक्वल टू 2, इसमें से एंड लिखेंगे तो हमें ऐसे बोलना पड़ेगा कि x इज इक्वल टू 3 और x इज इक्वल टू 2 और ही लिखना पड़ेगा. x इज इक्वल टू 3 एंड लिखोगे तो नहीं चलता. x की अब इक्वेशन की वैल्यू 0 नहीं आएगी फिर.
Okay. You are in a correct path. But you should explain in a nice way. You are not, ऐसे नहीं बोल सकते कि आप गलत हो, but you are in a correct way to get the answer. Just now I explain you with and without zero divisor. उसका ही use करना है आपको. While using without zero divisor, what you say, a into b equal to 0, then either a is 0 or b is 0. असत लिहितो ना आपण
Yes, ma'am.
without zero divisor ला.
Yes.
And whatever we discussed in our 8th, 9th and then standard, that is on a real line. And we know that R is without zero divisor, real line. Real number system is without zero divisor. So that's why we are using this. So it means that the condition of without zero divisor you have studied in a maybe in 7th or 8th standard. बरोबर ना? But at that time we don't know that this is what a condition of without zero divisor. क्योंकि a into b equal to 0, that is x minus 3 into x minus 2 equal to 0. Then we write either x minus 3 is equal to 0 or x minus 2 is equal to 0. That is what a condition of without zero divisor. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
So that condition we have already used in our 8th standard. अगर वहाँ पे आपको थोड़ा सा क्लिक होता था कि मैडम और सर, those who are a teacher, जो भी आपके थे, अगर आप उनको वहीं पे पूछते कि ये why we are writing or, because both are the roots, no? That is what I explained you just now, that for the condition of without zero divisor, either A is 0 or B is 0, but if both are 0, that is also okay, na? No problem. ओके, थिंक ऑन दिस, क्योंकि अगर मैं ऐसे ही एक्सप्लेन करूँगी तो नहीं समझ में आएगा। आप थोड़ा सा खुद से सोचो कि क्या होता है विदाउट जीरो डिवाइजर, एंड बिकॉज अप टू नाउ इन we have studied everything on a real line, so real line is without zero divisor. Okay, let us solve one more example for this third version. Find the extremal of the function. What is a function given? Integration 0 to pi by 2 y double dash square minus y square plus x square dx equal to 0, subject to the conditions are y of 0 equal to 1, y of pi by 2 equal to 0, y dash of 0 equal to 0, then y dash of pi by 2 equal to 1. Okay, these are the subject to the conditions are given. Now let us solve the example. Again, you can see the integral I is a function of x, y, y dash, and y double dash. There is a term of y double dash. So hence we have to now use our Euler-Lagrange's equation, the third Euler-Lagrange's equation. Okay, now in this case, what is your integrand f? We have been provided y double dash square minus y square plus x square. Okay, integration and dx ला सोडून जे काही असेल ते तुमचं f आहे. Okay, now let us solve this differential equation and we will find out what is extremal of the function. F with respect to y, it is minus 2y minus d by dx as it is. Derivative f with respect to y dash, it is 0 plus d2 by dx2 as it is. Derivative of f with respect to y double dash, 2y double dash equal to 0. Is it okay?
Yes, ma'am. Yes, ma'am.
Oh, now we can divide by 2 because 2 is a non-zero. We can divide by 2 and we can write the equation minus 5 plus d2 by dx2 y double dash equal to 0. Hence we get y fourth. Derivative of y minus y equal to 0. It means that our characteristic equation is r raised to 4 minus 1 equal to 0. Okay, now find out the roots and find the general solution. Okay, find the roots, find out the solution. Can you do it as a homework?
Roots are minus iota.
Plus or minus 1, plus or minus I. Okay. So C1 e raised to x, C2 e raised to minus x, and C3 cos x plus C4 sin x will be the general solution. Okay, now just substitute our initial condition and find out the values of the constant term. Put it as homework.
Okay, ma'am.
Yes, करू शकतात ना homeworkला?
Yes, ma'am.
Okay.
Yes, ma'am.
Now let us go for the next point, that is isoparametric problem. So what is there in isoparametric problem? A problem in which a function is eligible. Okay, I will write down the definition, read the definition carefully. A problem in which the function is eligible for extremization of a given definite integral or extremization of a given definite integral is required. मतलब आपका जो फंक्शन है उसको सिंपली एक्सट्रीमाइजेशन के लिए उस फंक्शन का जरूरत नहीं है, उसको और कुछ एक्स्ट्रा चाहिए. इज रिक्वायर्ड टू कंफर्म with a certain restrictions. Okay, because up to now whatever the three versions we have seen, वहाँ पे कोई restriction नहीं था ना, because we have imagined this that we have a no restrictions in our system. We are considering to be conservative system. Okay, but there may be some restriction on the motion of a particle. So that's why now the concept of isoparametric problem is introduced. Is called isoparametric problem. Okay, a problem in which a function is eligible for the extremization of a given definite integral is required to confirm certain extra restriction. Okay, up to now what we were doing, we are finding the integration. We are finding the extremization of integral I under the condition, suppose integration x1 to x2 f of x y dash. If we are discussing for this one, we were not considering about any extra condition, suppose due to air, due to some other restriction, due to rainy season, due to any other problem. If we are having any other problem, there will be some restriction on that integration, some restriction on the path followed by the object to reach from point P to Q. Okay, there might be some restriction from path P, from particular path from point P to Q, so that to avoid all this restriction, as we are finding the extrema of the integral I, we should go through that restriction. That extra restriction are now added to find out the extremization. Okay, up to now we were not discussing about the any restriction. Now we will add some restriction on our extremization of integral I. Okay, extremization find out करने के लिए हम कुछ extra conditions add करेंगे, because no doubt whenever you are going to find out the extremization, okay, अगर आप कोई suppose you are traveling from point P to Q with a minimum distance, that is a straight line, always it is not possible to go through a straight line. आएगा possibility?
No, ma'am.
Okay, suppose you imagine that you are in the physical classroom, and if you want to reach to the dais, okay, suppose you want to reach to dais, so directly you cannot come with a straight line, you have to come through this way and you have to then come to the dais. बरोबर? Okay, so every time it is not compulsory that you should go through the straight line. अगर आपको straight line से pass out करना है तो वहाँ पे कुछ restrictions होंगे. Okay, that restriction we are not going to add. अब तक हमने add नहीं किया था. So now we are going to add them with the heading isoparametric problem. Okay, imagine करा suppose you are traveling from some point A to B, and whether it is always possible to reach from point A to B in a straight line.
No, ma'am. No, ma'am.
क्योंकि इमेजिन करो कि आप फर्स्ट फ्लोर पे हो और आपको ग्राउंड फ्लोर पे आना है, तो वेदर यू कैन गो इन अ स्ट्रेट लाइन, नॉट पॉसिबल. यू हैव टू कम थ्रू द स्टेट्स आर नॉट इन अ स्ट्रेट लाइन ना. अगर आपको स्ट्रेट लाइन में आना है तो आपको डायरेक्टली जंप करना पड़ेगा, राइट? So always it is not possible to come through a straight line. Those restrictions Now we'll add with the help of a condition of isoparametric problem. Okay, so now let us go for the first version जो हमने initially देखा था f is a function of x y y dash, that we will see with the help of a restriction. Okay, now let me write down the statement. The first one with the heading of isoparametric problem. Obtain the Euler-Lagrange's differential equation. Obtain the Euler-Lagrange's differential equation which must be satisfied by the function which extremizes the integral I, which is from x1 to x2 f of x y y dash dx, subject to the condition. यहाँ पे extra condition आ जाएगा, right? Subject to the condition the integral j has to be considered at that time. Integration x1 to x2 g of x y y dash dx equal to some constant. So next, what is next condition given? Y of x1 equal to y1. That is, endpoints are given. Y of x2 is equals to y. Okay. So in this way, we have to find out the extremization of integral I. We have to find out extremization of integral I under the condition j. Okay. The value of integral j equal to some constant, that is some restriction is there on the motion of that particle, that is maybe due to air, due to rainy season, due to not going through a straight path, there may be some restriction on a straight line path. So those we can give them some name, that is integral j with g of x y y dash dx equal to constant. ओके, ये वाला हमने ऑलरेडी देखा है, बरोबर ना? इसके लिए हमने डिफरेंशियल इक्वेशन भी फाइंड आउट किया है, बट नाउ वी आर गोइंग टू ऐड one integral j which is a restriction, and then we will find out the new Euler-Lagrange's equation. Okay, so let us end here because it will not be completed in this time. We'll continue this in the next lecture and we'll go for the examples of this. Okay, similarly, in the very similar way, we'll go for the all the 6 version and then we will complete our second unit. Okay, be prepared for the exam. You have to go through the exam, and one more thing I want to tell you, that whenever you are going to study any paper, you should at least write down once without looking. Okay, try to write down without looking, then only you will be able to understand what you have written, what you have studied. क्योंकि यहाँ पे हम अगर टीचिंग करते हैं तो आपको ऐसा लगता है कि हाँ this is very easy, but if you close the notes and if you want to imagine, then at that time it will be not possible for you. हाँ, exceptional cases are there जो कॉन्सेंट्रेटली लेक्चर सुनते हैं या फिर जिनका IQ लेवल बहुत ज़्यादा है, so they can remember this, but for averagely I am saying that at least once you should write down without looking. ओके, ऐसे कंसिडर मत करो कि हमारा MCQ एग्जाम होगा तो हमें क्या जरूरत है लिखने की, why should we study and all. Okay, this is for you only because after the completion of MSc all will think that you are knowing all this concept. Okay, so सिर्फ MCQ के एरिया में ही स्टडी मत करो, you should go beyond and that, and you should study well, like you want to take a knowledge that what is a classical mechanics. क्योंकि अगर कोई चीज आप कर रहे हो तो कॉन्सेंट्रेटली फोकसली उसी को करो. ओके, 2-3 चीजें एक साथ नहीं करना चाहिए. हाँ, नो डाउट यू शुड हैव अ प्लान बी, बट ऑन द कंडीशन इफ प्लान ए इज नॉट वर्किंग. ओके, सो जो भी कर रहे हो कॉन्सेंट्रेटली करो. Okay, don't think that we will give MCQ exams and it will be fine and all. So for every paper I am saying, not for only classical mechanics, for every paper we have